Hey guys, I just said in a previous lesson, this is like the third time I've recorded that lesson. Well, guess what? This is the third time I've recorded this lesson. I went through a full, what I thought was a beautiful recording on this last version. There's no audio. I had myself muted the whole time. Okay, so here we try again. All right, we're going to be talking about exponential growth and decay applications, and we're going to be using a lot of technology today. And for Algebra 2, we're really going to focus on how your technology can help you answer these questions. So by that, we're not going to have super duper accurate answers. Like, we're not in a position to do things so accurately where like it's a life or death situation. We're going to get a lot of answers today that are like about this many minutes, between this many years, and that's okay. So let's explore this function a little bit more. What we see here is essentially an exponential growth and decay. But because they're applications, we have to investigate further about what that base means. So if you have a quantity in real life that increases at a fixed percent, and it says each year, but it's not always a year, but each time period, you're going to have what's called an exponential growth model. So a couple of things to pull out of this paragraph you might want to highlight. A is the initial amount, and that's going to go for growth or decay. R is the percentage written in decimal form. And then there's one more variable in there. They use T for time. And again, it's not always in years. That's a little misleading. That 1 plus R is called the growth factor, and 1 minus R is called the decay factor. We know it from our previous lesson as being known as the base. So the fact that you can separate the 1 from how far it's growing or decaying is essential for these questions because they're applications. So similarly, we have exponential decay. In those cases, the functions would be decreasing every time interval. All right, so here, this is classic science. So I just gave you an equation that started off with y equals, and then science comes in and they're like, no, I think I want to start with an a. So if it bothers you, just go ahead and make that a y, all right? So let's read the paragraph, or the sentence here. It says, a scientist estimates that a specimen begins with 730 bacteria. So that number right there is your initial amount, your a value. So that's going to go in front, if I think about that formula. Then, in the parentheses, for that factor, it says it's growing by 35%. So right there, they're talking to us about the R. So because it's growing, we're going to be adding, and then remember 35%, the decimal version of that would be 0.35. If you forgot how to convert percents to decimals, you can either move the decimal to the left twice, or you can take the percentage and divide it by 100, because literally percent means out of 100, and that's how you're going to get the 0.35. Okay, so that being said, our growth factor ends up being a 1 and then plus 0.35. And then they just want me to write a model, which means my variable here is exactly that. It stays as a variable for now. So I'm going to use t, because that's what they had in my model, but if you used x, that's totally fine. So this next question, this is where the technology comes in. How many minutes pass before the bacteria reaches a population of 9,000? So how many minutes is the question. Anytime it says how many minutes, that means that we're going to program our calculator to go to y1, and we're going to type in our function, and then we're going to go over to our table. So somehow you want to indicate on your notes, anytime the minutes or the time is unknown, that means you have to use your table. So what we're going to do is in y1, we're going to program exactly what we have typed here. The only change is we're going to change the t for an x, because that's the variable that we use. I'm not even going to clean up the 1 plus 0.35. If you called that 1.35, that's fine, but your calculator doesn't really care. So on my next slide here, I gave you a little picture of the calculator. I feel like sometimes where the issue comes into note-taking is like you're working on the calculator, you're watching the page, the video, you're filling out the notes, and you don't necessarily get all the information in one place. So what I would do is I would start highlighting or circling buttons on this picture that we used. So we're going to go to y equals, and we're going to type in our function, which I wrote down on the other slide, but I think I kind of remember it. We'll see. All right, 730. You don't even have to simplify the 1 plus 0.35, but you can. And then it's very important that you don't forget that to the x power. So because we're leaving time as a variable, it's going to give us a whole bunch of answers for a various amount of times. Now, and we use that x key for the variable right there. So the next place we go is to the table. So second graph is how we get to the table. So back to my notes for a minute. I'm going to adjust that a wee bit. We used this key, right, for the x. And then to get to the table, we had to use the second key. So this is where you go to get to the table. Okay? Note to self, right? So in our table, this is telling you how much bacteria you have at any given time. Now, obviously, negative time doesn't make any sense, but after 1 minute, there's already almost 1,000 bacteria. Bacteria grow very fast. So if I keep scrolling down, here there's 3,000 or so bacteria, and they want me to know where it hits 9,000. So I'm going to keep scrolling until I see it has surpassed the 9,000 mark. And it would have happened right here in between 8 and 9 minutes. So that is what I fill out here. So the answer is about or around 8 to 9 minutes. And I pulled the label of minutes from the problem because it said it was growing every minute. But we still need to write down some notes about what we did on our calculator, right? So we went to the table, and then our table had this look to it, right? X and Y1. And then we scrolled until we see this number over here about hit 9,000. It didn't exactly hit 9,000, but that's okay. I don't really know that I'm passionate enough about the bacteria to know the exact answer. Later we'll find techniques that do allow us to find the exact answer. For now, we're just going to estimate. All right, moving along. This problem, we have a car that is depreciating, right? That happens to cars when you buy them, and the minute you go away from the dealership, they're already worth a whole bunch less. So we start with the car's value of $36,000. That's that A value. And then it says it's decreasing 14% each year. So that is your rate. And because it's decreasing, we're going to use the decay, so the subtract 0.14. So when I go to write the exponential model, I didn't give myself a lot of room here. Sorry. We're going to write y equals that initial amount of 36,000. And then in the parentheses, we have 1, and because it's decaying, it's a minus 0.14. And then this is the important part to the model. Models are general, so you can either put a t or an x up in the exponent, because they want a model that fits the situation for all time. They don't want just like a certain year in this question. They want the general model. Now the second question, it says find the value after 3 years. So here, because you know time, that means you can do this work in the home screen. Because literally all you need to do for me is plug in a time of 3 years. So in the home screen, which I'm going to write down here, my work, I'm going to type in the model, but I'm going to plug in a 3. So I'm going to type 36,000, 1 minus 0.14, not even going to simplify it, and then to the third power. Now with this being money, let's round appropriately. Let's give it to the nearest cent. So it was 36,000. I'm in the home screen here. And then times 1 minus 0.14, I think. I hope that was it. And then after 3 years, how much is this baby worth? All right, so that car is down to $22,898 and 2 cents. Oh boy. $22,898 and 2 cents. So that was the answer to part B. All right. So now let's look at part C. I really needed to give myself more room. I apologize, guys. So for part C, this time it says graph the model. We're not going to do that part. We're going to use our table to figure out when the car is worth 15,000. So this is a case where I don't know how much time, right? Time is unknown. So we are going to use our y equals on our calculator. So in y1, we're going to type 36,000. Now this is a little tricky for kids because they're like, wait, we just knew time was 3. Well, that was only for one particular moment in time, right? I want my car to go down to 15,000, so I don't know the time. 1 minus 0.14, which means I leave time as a variable, as x. All right, to our calculator. Now this time, we're in the y1 menu. The reason I didn't type that other problem into the y1 menu is because I knew time. I knew time was 3. If I just put 36,000 and then 1 minus 0.14 to the third power, when I went to my table, it would just give me like a whole bunch of stuff. I'll show you what I mean in a second. But well, I'll show you another way that we could get this question right, the previous question right. All right, important part right here, to the x power, make sure that's got a variable there. All right, let me show you what I'm saying here. Remember how that last question was 3 years? Well, if you go down to 3 years in your table and you highlight over that number, it'll give you that same number. So this is your calculator plugging in a whole bunch of numbers. So that's nice. But I don't want that much. I want 15,000. So I scroll down, and it happens right around there. And again, I don't have an exact answer, but somewhere between the 5 and 6 year mark. Probably a little closer to 6, but they don't ask me that much. So I'll say between 5 and 6 years. Yeah, a lot of people do this where like they know what their car is worth and they sell it before like their loan is up, so that way they can recoup a little money, and they don't plan on keeping it for the long haul. All right, in hindsight, I should have separated this a little bit. Some other notes to yourself on this question. So when you went to your table, you had your table, it was XY1, and then you just kept looking, look. It didn't take you very long to see when it hit about 15,000 over here on the Y equals side. All right. So, yay technology, making our life a little easier, like always. This next question actually doesn't require any technology. We have an antique table that after the year 1975, it starts growing in value. So that's the equation where it's a growth. And the first question is, what was the table worth in 1975? So they're really asking you for the original amount. So that's just part of the formula, isn't it? Isn't it just the A value? So I'm just going to pull that straight out of the equation, $325. You could have plugged in a 0 for T and calculated the 325. It would have worked out nice. Now this next part we got to be careful about, the growth rate. Now in the parentheses there, remember that's 1 plus our growth rate, excuse me. So for us, that's like 1 plus 0.03 if I kind of separate it from the 1, which means that guy is the growth rate. Now you can either write 0.03 or you can call that 3%, which makes a little more sense. What I don't want to see is 0.03%. That's really wrong. So this or this. Okay, I've seen that question a lot on the No Calculator SAT. So not that exact question, but something like that, where they want you to come up with an obvious characteristic of the equation. Oh, the compound interest formula. So this one, as ugly as it looks, it's really inherently just an exponential growth question. The only difference is instead of your interest typically collecting one time over the time period, it collects multiple times. So this is usually the way your bank accounts and investments will roll, that you'll get interest payments quarterly or daily or monthly. And that's where this N is coming in. So with this being an application, they did it again. They're like, you know what? Let's just scrap everything we've been doing and let's call it whatever we want. So in financials, they call the initial amount that you invest, your initial deposit, they call that the principal. So the number in front, which we used to call A, is now called P. Thanks for confusing everyone. Good news is they still use R for interest rate. And again, it's still written as a decimal. The other thing that's still the same is T is still time. And again, it's not always years, but it's the number of whatever the time value is. Typically years, but not always. And then this is the new one. N is the number of times that you compound interest in 1 year. So the N shows up twice in the formula. It shows up here and here. Oops, I forgot about the T here. It's times T right there. So this is a little confusing for kids because they think like, oh, if I invest and I get quarterly interest payments, that means they're going to give me all my interest 4 times a year. It means they're going to give you a portion of your interest 4 times a year. They're going to break it up into little tiny installments where you get a little more than you normally would have gotten, which does accumulate more money. It just doesn't accumulate as much money as we would think. Let me kind of demonstrate that for you in this question. So we have $1,000 that we're investing, right? So that's the principal right there. And it pays 8% interest. That's super high, by the way. You're never going to find like a savings account with 8% interest. And it does say 1 year, so there's your time. And then they're going to change the N. So for this question, annually means 1 time a year. Quarterly means 4 times a year. And daily, just to simplify our math, we'll call it 365, but some of you recognize that there's not actually 365 days in a year technically, but we go with that. Okay, because we know time, All of these are going to be on your home screen. So write a little note that everything like this would be on a home screen. And what I'm going to do is I'm going to write out what I'm going to type in the home screen first, and then I'm going to show you how you can use your calculator to kind of save a little bit of time. So the interest formula starts with the principal, so $1,000. And then there's a big ugly mess of parentheses. So we got 1 plus the interest rate, remember, was 8%. So this guy converted to a decimal is 0.08. And then we're going to divide it by n. So once annually, it's 1 time. I know that feels silly. Like, why would you divide by 1? But just write it down anyways. And then up in the exponent here, and I'm going to put parentheses even though I don't need them on my newer calculator. The older calculators do need them. So that n shows up again, 1, and then times how many years. And we're only leaving the money in for 1 year. So again, I'm looking at that going, 1 times 1, that's 1. Why do we even bother? Just write it down. Okay, so that's the first question we're going to type in a moment. The next question, the only thing that changes is the n. The n is now a 4. All right. So this is going to divide by 4 now. And then up in the exponent, that n changes to a 4 as well. But it's still times 1. So there's definitely going to be a change. And I'm thinking you can anticipate which one will give you more money. It just might not be as much money as you were hoping for. Now, if this was an interest payment where I had to pay the interest back, then I'm not real excited about making this number get big, so keep that in mind. All right, 0.08, this is daily, 365 is what we're changing those blue numbers to. Oops, I wrote too big, what a shock. All right, so 365 times 1 up here in the exponent. Okay, so in theory, I'm going to type all those into the home screen, but I'm going to show you how you can use your calculator to reuse an entry from before. All right, I'm going to type that first one in. Home screen, here we go. All right, so we had, I already forgot, it was 1,000, I think. 1,000, parenthesis, and then 1 plus, it was 0.08. I know it's silly to divide by 1, but I'm going to write it anyways. I'm going to close that parenthesis, and then on the newer calculators, all you got to do is go up into the exponent. You don't have to use extra parentheses here. If you're on an older calculator, you're going to need to put parentheses around that. If you chose to use parentheses here, guys, it's not going to do anything. It's not going to give you the wrong answer. It was 1 times 1. And if you chose to simplify that to a 1, even better. All right, so we have $1,080 in that bank account. Yeah, where'd it go? All right, so right here, $1,080. So you made $80 interest, not too bad for 1 year. Like I said earlier though, like hate to be a Debbie Downer, you're not going to find an interest account for 8%. All right, now rather than typing all that in again, I'm going to show you a neat feature. On the newer calculators, you can just go up and you can hit enter on a previous entry and it'll bring it back down to like the edit screen, and then you can go ahead and adjust it. So remember those ones, this one here is now a 4 in this next question. And then this one here is now a 4. I will warn you when you do that, it overtypes stuff. So if you needed to make a 4 into a 12, you might have to put like a insert space because it's just going to keep overtyping it. So sometimes I find it's easier for me just to retype the whole thing because I keep messing it up. All right, $1,082.43 totally. So not really that much more money. And maybe you weren't impressed because you're like, well, yeah, it was only 4 times as opposed to 1 time. But 365 times, that's got to be better, right? And it'll be better. This one I'm just going to type fresh because I got to type 365 and it's going to be weird. All right, so 1 plus 0.08. Now it's being divided by 365. And then up in the exponent, that 365 shows up again. I'm supposed to say times 1, so I will. It's like hardly any more money, guys. $1,083.28. Oops, $1,083.28. So I guess the question is why? Like, why is it not a ton more money? We collected interest like 300 and something times more than we did on the previous questions. It doesn't give you all the money every single day. It gives you a teeny tiny fraction. If you think about that equation, the formula, the r being divided by n is what really kills the growth, right? So 8%, but it's not growing 8%, it's growing 8 divided by 365 times. So it's actually very, very, very tiny, but it accumulates over time. So like on January 2nd, you get a teensy bit more money, and then January 3rd, you get a teensy bit more money even more. So it accumulates, it builds interest upon your interest. The other thing I would point out in that question, they only invested it for 1 year. So you're not going to see a huge discrepancy between the different variables and the ending balance. But if I left that money in for like 20 years, you'd see a much greater difference because the one is going to grow much faster over time, which is kind of neat to think about. All right, so this next question, we have how many years? So right away I notice they don't tell me time, which means I need to use my table. So I'm going to have to use Y1 and then use your table, and it clearly says right there, use your table. So that was the dead giveaway. If you don't know time, you have to use your Y equals. Now this question messes with kids because all it says is, I want your account to double, but it doesn't tell you how much to initially invest, right? So for the principal, you can literally invest any amount you want. So I just need to invest something that's easy for me to do mental math with. So I'm going to, for me, I always do $100. Wow, you can't read that. Mrs. Meyer, because she likes to dream big, she always invests $1. So I invest 100, she does 1, you can do 1,000. Just don't go too crazy, okay? And make it something nice that you can easily mentally double. So we're going to collect 4.5%. So there's your interest rate. If we write it as a decimal, it's 0.045. And then it's compounded. I used the wrong color here. I should have used another color. My bad. It's compounded monthly. So that right there tells us that our N is 12, because 12 months in a year. All right, so what we're going to do is we're going to go to Y1, and we're going to type in our equation. So it starts with $100 for me, $1 for Mrs. Meyer, and then 1 plus the 0.045. It's being divided into monthly payments, so 12. And then up in the exponent, that 12 shows up again, but I don't know how many years I have to leave it, right? So I have to call that an x or a t or some sort of variable, but because I'm using y equals, I'm going to use an x. Now remember, our older calculators have to put that put the parentheses around that exponent. All right, to the calculator. So we're in y equals, we had $100 for me, 1 plus 0.045. We divided it into 12 months. Close your parenthesis before you go to the exponent. And then the most common mistake on this question is kids forget to put the x for the time. You have to put 12x because it needs to have a variable time, right? All right, here goes. So to our table. Now remember, we wanted our money to double. So if I invested $100, I'm going to be looking over here for it to hit $200. That would be double. Right about there. All right, so about 15 to 16 years. For Mrs. Meyer, she was looking for $2, and guess what? Guys, she got the same answer. So on our table, when we are looking at our table here, what we had to do was we had to look for our money to double. So I had to look for my money here to hit about $200 because it wanted it to double. Okay? So if you invested $1,000, you'd be looking for $2,000. And either way, we got an answer of 15 to 16 years. About 15 to 16 years. Kind of smack dab in the middle, if I believe. Remember that. Now, this one really blows kids' minds. There's something called continual interest, and that means that you are getting interest every hour of every day, all the time. So that formula is right here. And once again, they get a little weird. They keep similar variables. They use P for principal still. But your base, your growth factor, isn't this 1 plus R, blah, blah, blah. They use the natural number e. We're going to learn a lot about the natural number e coming up in logarithms, but it's a number. E is approximately 2.718. Like how pi is an irrational number, e is a different irrational number. And then up in his exponent, you have the r times t. So for this question, we've got $1,000 collecting continual interest at 8%, and then for 1 year. So there's t. This is kind of the r. Remember, we got to change it to 0.08. And then there's your principal. All right, here goes. So because we know time, these problems will be in the home screen. We don't need to use the y equals on these questions. And in the home screen, we're going to type 1,000. I'll show you where to get the e in a second, but we're going to multiply it by the number e. And then up in his exponent, which again, you don't need parentheses if you're on a newer calculator, you're going to raise it to the 0.08 times 1 power. All right, to the calculator. So there's two places that you can find the e. There's one right here above the division key, but that is literally just the number e, the 2.718. Because we also want to follow up e with a caret, you can get that in one step if you use this e that's over here above what's called the natural logarithm. So e to the x power is the button I'm going to use. So I'm going to type 1,000, and then I'm going to use shift natural log, and that brings up e, and then it automatically goes up to the exponent, which is nice. So 0.08 times 1 year, and then continual interest, and we hardly get any more money, but it is more, 1,083.29 cents. So again, the same fact of, yes, the continual interest, but you don't get all of it all the time. You get little teeny bits. Okay, this next question is very similar. New principal, though. We have $800. Continual interest at 7%. So up in your exponent here, it's 0.07. And this time they left it for a little bit. They left it for 3 years. So if you're on an older calculator, make sure you use parentheses up there. Alrighty. And these are not anything you can do in your head. E being a natural number does not mean mental math is your friend. Yeah, I have no idea what this is. Apparently it's 986.94. I feel like I typed something wrong there. See, this is where I really miss you guys, because if I'm doing something stupid, you would have just told me, right? Okay, so that's our friend continual interest. So what if I ask you one of those weird questions with continual interest? So, it's a loud bell, sorry about that. Again, how long will it take for my account to triple? So for the principal, it could be anything you want. We just have to make it triple in our table. So for me, I'm always going to go to $100, always. All right, so it does say use your table. So we are going to be using our table, which means in Y1, we're going to type $100, or if you're Mrs. Meyer, you type 1, and then use the number E, and then up in his exponent, it's 5% continual, so that's why the E's there. So 5% is 0.05, and this is the part everyone forgets, for a mystery number of years. I don't know how many years. You got to put an X, okay? So on our table, what we're going to do is, we got that XY1 table. I'm looking for my money to triple, so I need to look for my money to get about, so $100 tripled would be $300. All right, here goes to the calculator. So in y equals, type in my new function, 100 e, which is this guy right there. Already brought up the exponent, so 0.05, and then don't forget the variable x. All right, let's see how much time will it take for my money to triple. Ooh, real stinking close to 22 years. So I'm going to say about 22 years. Took my face there. Okay. 22 years. If you invested $1 and you looked for $3, you also would be getting 22 years. If you invested $1,000 and looked for $3,000, you also would be getting 22 years. It doesn't matter how much you invest. The point is it's going to take you 22 years to triple it. So since your money has to sit down there for a while, I suggest you get busy on your investments. All right. Good luck, everybody. I know this was crazy, really heavy on the calculator. Go back and kind of highlight on your calculator on the paper which buttons you were pressing. I think that's a good way to take your notes. All right. Good luck.